D-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. Liftoff of the Falcon 9 rocket with science for today and for deep space exploration tomorrow. Falcon 9 has cleared the towers. Good evening, everyone. This is the post-launch news conference for our SpaceX CRS-8 mission tonight. And here to join us to give us a status on our launch and our mission is Kirk Sharman, manager for the International Space Station program at NASA's Johnson Space Center. Elon Musk, the SpaceX Chief Executive Officer and lead designer. And Hans Koenigsmann, the Vice President of Flight Reliability for SpaceX. And we'll start first with Kirk Sharman. Kirk?
All right, thanks. What a wonderful day. It's a beautiful day outside, a great day to launch a rocket, and we saw a great one. So I had the pleasure of being in the Mission Control Center at SpaceX, and I can tell you the folks were really excited, as were myself and Bill Gerstenmaier. And then we could hear the roar of the rocket. That was really cool. So after the launch, I got on the phone and talked to our colleagues in Houston, and there was a roar there too. So it was great to hear that. We're very excited to have our cargo and the Dragon safely on orbit, and we're very much looking forward to it to arrive to the ISS. I had a chance to speak to our mission control room in Houston, and all systems on board the ISS are ready to support the mission. And like I said, we're looking great, very forward to having the cargo and all the utilization on board ISS. Tim Peake will be grappling the Dragon at 6:12 a.m. Sunday Central Time, and Jeff Williams will be assisting him, and those crew members are ready to support that operation. And like I said, we're really happy to have Dragon up in space, and we'll be even more happy to have it on board ISS. So let me hand it back to you, and we'll hear from our SpaceX colleagues.
All right. Thank you, Kirk. Now to Elon Musk, our SpaceX CEO and lead designer.
Thanks. Well, it's great to be here. Just of course, we love doing a good job for NASA. So thank you for allowing us to deliver the cargo.
Mm-hmm.
Yeah, I think the mice are doing well. That's what I heard.
I'm not sure they're happy though.
I think they might be a bit confused.
Yes.
So it's probably not on their evolutionary path to be in zero G, but yeah, there's a bunch of astronauts on board. So the thing that was a little different about this mission on the rocket side was, of course, the rocket landed instead of putting a hole in the ship. Or tipping over. So we're really excited about that. And the reason that's really important is about half of our missions will need to land out to sea. So any missions that are going to, particularly to geostationary orbit or to escape velocity, anything beyond Earth is likely to need to land on the ship. And I thought it'd be worth just emphasizing that the reason for that is something that I think it would be good for the press to educate the public about, which is the difference between space and velocity, space and orbit. Like arguably the space station should be called the orbit station because it's actually zooming around the Earth at 17,500 miles an hour. And it crosses the Atlantic in, I think, about 20 minutes or so. It's pretty speedy. And that's, for example, why there's such a short launch window, is because the rocket's got to get into orbit and kind of match the orbit with the space station. And it's it's moving so quickly that that orbital window is only open for a few seconds. So although a rocket looks like it's going up because it starts off vertical, actually it's going to very quickly turn and go sideways and go horizontal, and it's going to match that space station velocity of roughly 17,000 miles an hour. So basically, the rocket at stage separation is zooming out to speed zooming out to sea at an incredible velocity, and it doesn't have enough propellant to come back to basically zero out that velocity, boost back in the other direction, and then land. So in order to achieve effective reusability, if you want missions to go to high orbit or to escape velocity, you really need the ocean landing. I just wanted to make sure that was explained, and we can, in the Q&A, we can go maybe into a little more depth on that. But I think as things make progress, I think it is. I think it would be good for the public to know a bit about orbital dynamics, because it is a little counterintuitive. So anyway.
Thank you, Elon. And now to Hans Koenigsmann, our Vice President for Flight Reliability at SpaceX.
Yeah, I just can fill in a little bit on the Dragon side. I talked to mission control on the way up. All thrusters have been fired, so we know Dragon's healthy. It's a good spacecraft. Everything's working. Our flight computers are running. Comm is working. Communication is working. The next thing that's going to happen is the opening of the GNC door, which then will activate Star Tracker. That is going to happen in about 2 hours and 15 minutes, and then the first orbital adjustment burn is going to happen in tomorrow morning, and docking with the space station then is currently planned for Sunday morning. I think 6 o'clock. Early in the morning at Eastern time. So everything is going well. It's an awesome day. I think the team, both on SpaceX side, on NASA side, and also on the 45th side, worked awesome together, and we did a great launch.
Thank you, Hans. And we'll take questions now. Please give your name and affiliation when the microphone comes to you. We'll start right here. It's with James here.
Sorry. Sure. Thanks so much. James Dean, Florida today. Elon, do you think this booster, if it checks out okay, will be the first to refly? How soon could that be?
Yeah, that's a good question. I think that that's likely. So the plan is to bring this booster back. Should arrive in port on Sunday, and then we're going to do a series of test fires. We're hoping to do that at the Cape, rather than transport it to Texas and then bring it back. So our thought is to basically fire it 10 times in a row on the ground, and if things look good at that point, we feel it's sort of qualified for reuse in launch, and we're hoping to relaunch on an orbital mission probably around May or June, so it's pretty soon. May, let's say June. Try to recalibrate my timing expectations.
Just clarify that you could relaunch this booster within a few months.
Yeah. Well, in the future, hopefully we'll be able to relaunch them within a few weeks.
Irene?
Thanks. Irene Klotz with Reuters. Congratulations, first of all. And with this, would that be a test flight, or would you hope to have a customer for that? And also, this has been kind of a long time coming for you. How do you feel about this, and were you surprised to actually see it stick the landing?
Yeah. We were just talking yesterday, went around the table on odds for success, and the consensus was about 2 to 1. So we thought it was more likely than not that this mission would work, but still probably 1/3 chance of failure. But we'd eliminated the reasons, the prior reasons. So we were confident that if it did fail, it would fail for a new reason. So as it turns out, there's a lot of reasons for rockets to fail.
Mm-hmm.
So But this is a beautiful day, and I think the circumstances were good. It's still quite tricky to land on a ship, and if on the video, I mean, the ship looks quite small relative to the rocket, so it's quite a tiny target. It's really trying to land on a postage stamp there, and it's moving, sort of translating and rotating. It's sort of like a carrier landing versus a land landing. It's a tinier spot, and it's moving.
The use of the reflight, would that be an actual paying customer on it, or would you do that just as an experiment to relaunch it?
We think it'll be a paying customer, but that's we got to have some discussions. So, yeah.
All right, let's go right here.
So, Elon, having achieved this this milestone here, what does that mean for the future of SpaceX and for the future of spaceflight?
Yeah, I think this is a really good milestone for the future of spaceflight. I think it's another step towards the stars. In order for us to really open up access to space, we've got to achieve full and rapid reusability. And being able to do that for the primary rocket booster is I think, going to be a huge impact on cost. Now, it'll still take us, a few years to make that smooth and make it efficient, but I think it's proven that it can work. And there probably will be some failures in the future, but we will iron those out and get it to the point where it's a routine. It's routine to bring it back, and where the only changes to the rocket are, maybe to hose it down or clean, give it a wash and add the propellant and fly again. That's the key. Full and rapid reusability is fundamental. Yeah.
Bill?
Oh, well, Marcia was ahead of me. I'll let
Oh.
Marcia go in front of me.
Okay, Marcia, go ahead.
Marcia Dunn, Associated Press for Mr. Musk. Where do you expect the stage that landed in December on land, where's that going to end up? Is that going to be on display at your headquarters
Yeah,
ultimately? And
soon,
and
hopefully.
hopefully, is
Yeah.
that the plan?
We just got our headquarters are close to or adjacent to the Hawthorne Airport, so we needed FAA permission because it would be like the highest object for quite a distance around the airport. But we just, I believe, got that permission. So we're planning on putting the rocket that landed back at the Cape in front of the SpaceX headquarters in Hawthorne, hopefully in the next few months.
Oh, okay, thank
Yeah.
you. And could you tell, what was the velocity and the altitude for this booster? What's the highest altitude it reached in its peak speed before it started coming back?
So actually, I don't actually know.
200 usually.
Yeah, for LEO missions, the peak altitude is usually not super high. Like it's would have been something around a couple hundred kilometers, and the velocity also is not as high as it would have been on the last mission. The highest velocity missions that we see are the geostationary missions. So for example, for this mission, actually we could have brought it back to land, but we wanted to do a ship landing where we had lots of margin. So it would have been a low margin return to land or a high margin ship landing, and so this, I think, really helped us show that the ship landing could work. But in terms of the maximum sort of transfer velocity, which is this is really the key figure of merit for the boost stage. The maximum transfer velocity is we think we'll get up to about 9,000, maybe 10,000 kilometers per hour. And that's transferring an upper stage load, upstage with payload plus fairing. You talk about 120 tons or thereabouts. So it's 120 tons to upwards of 10,000 kilometers an hour. So it's sort of quite a javelin throw.
Bill?
Yeah, Bill Harwood, CBS News. Two very quick questions. One is, I realize it's a fairly calm sea today, but those of us not used to looking at barges in the ocean, looked like it was rocking pretty good. What is, just out of curiosity, the maximum tilt the rocket could stand and stay vertical, number one? And two, can you talk a little bit about increasing your launch pace? You guys have a really busy manifest. You're starting to ramp things up here, and do you need more people? Can you do it with the crew you currently have here and at Vandenberg? Just generally about the pace. Thanks.
Sure. Well, first of all, I'd say it's a ship. It used to be a barge, but when we added engines and control systems and everything, so now I think it's sort of fair to call it a ship. Has 4 engines, but today the pitch and roll was about 2 to 3 degrees, so it was actually not too bad. In terms of maximum, well, probably, I'd say we could do double that easily, and maybe triple. So maybe it's 8 or 9 degrees, but that's probably about the limit. But that would be really intense seas. And you also see some translation where it's going up and down, so it's both rotating and translating. So it's tricky, just like a carrier landing. But it's, and both are going to absolute position. So the ship is holding to absolute GPS position with a relative GPS, and today was actually holding to with accuracy of below a meter. And it's got 4 engines that all of which can rotate 360 degrees, and they're operating continuously to hold both the attitude and position in the ocean. Yeah, in terms of increasing our head count, I think that's going to continue to grow, and our launch rate is going to continue to grow. We're expecting by maybe the third or fourth quarter that would be doing a launch every 2 to 3 weeks.
Stephen?
Thanks. Stephen Clark from Spaceflight Now. A couple of clarifications. I believe earlier you've talked about securing the rocket on the drone ship with welded shoes. I was wondering if that's still
that's what's happening.
That's still
We're
the
welding
plan?
it down. Yeah.
And
make sure it doesn't tip over. There's potentially some heavy winds coming in. So once the rocket's safe, the crew's going to go on there, and then we've got these steel shoes that we put over the landing feet and weld it to the deck.
And one more clarification: is it still coming into Port Canaveral? Is that the plan?
Actually, I'm not certain about that. I think that certainly is where it will ultimately be. I'm not sure if that is the initial destination.
Okay.
All right, let's come back over here on this side of the room. Right here.
Sawyer Rosenstein with Talking Space. Kind of going along with that, can you talk a little bit about the process of exactly how it gets, to that drone ship, how it stays on that drone ship, and then the process of what exactly happens from now that it's on until it gets back into port?
Sure. We're a little bit like the dog that caught the bus, what do we do now? But the plan is to bring it into port, then take there's a load head fixture that we can put on the top of the rocket, kind of where the stage separation mechanism attaches, and then we can pick it up with the crane and then put it onto land. And then we've got we actually have like a stand that we put it on, and then the stand attaches the launch hold downs, and then we can fold the legs up. Then the crane rotates it horizontal for transport, and should bring it back to probably 39A, and then we're going to do those 10 test firings, and if that all goes well, then we think we'll be comfortable with an orbital flight.
Okay, right here.
Jason Ryan with SpaceflightInsider.com, and I kind of want to take back a little bit to Orbcomm OG2 this past December. You successfully landed at landing zone 1, kind of carrying out a test flight there, and today you carried out a test flight more or less on ocean. So can you talk a little bit about SpaceX's plans to actually incorporate the testing of its technology successfully, I might add, while still sending payloads to orbit? Thank you.
I'm not sure I totally understand the question. So You mean, I'm not sure I understand the question. Incorporating SpaceX's technology to...
Test flights while you're still sending payloads to orbit. I mean, most
Oh, yeah.
people, they break up their test program away from sending payloads to orbit, but you've actually managed to incorporate the two. Can you talk a little bit about that philosophy?
Oh, yeah, sure. Well, I guess the problem with, as soon as you're going to orbit, your horizontal velocity, and like I really can't emphasize horizontal velocity enough. It's because it's so counterintuitive. It's super high. So it's really hard to do these test flights without actually going to orbit. Like we could conceivably, I suppose, put a huge weight, 120-ton weight on top of the boost stage, and then do these launches, drop the 120-ton weight, and then try to land. But there's no point doing that. Why not just send a useful payload while you're at it instead of the dead weight? So, but that's why it's really hard to do these tests. It's really basically impossible to do these tests on land, unless you had like Siberia or something, because it's just if something were to happen and the rocket engines didn't relight, it would have a ballistic trajectory and land like hundreds of miles away, like several, like, anywhere from 500 to 1,000 miles away. So it could randomly smash down on a city somewhere. That's why you want to do the ocean launches. So if it isn't able to turn around and relight the engines, then it's going to sort of smash into the ocean harmlessly.
Yeah, we are taking questions from social media as well. If you use hashtag #AskNASA, you can also ask some questions. Let's come here to the front to Daryl.
Daryl Nail, Fox 35. This would seem like a big week for you, your car company earlier in the week. Big moment for your aerospace company today. Can you kind of talk me through what that moment was like? Two questions. What that moment was like, where you were watching it, what you were feeling. Did you turn and hug Hans, or did you knuckle bump him?
I have a confession to make. I did indeed hug Hans. Yeah. Yes.
And then the tilt of the rocket when it came down.
Yeah, absolutely. It was. I think the whole SpaceX team was super excited. They've all worked incredibly hard to get to this day, and still a lot of work ahead for sure. Because making the landing and the reflight easy is hard, rapid and complete reusability is the thing that's really important for the reusability to be cost effective, like an aircraft. So if an aircraft, you can recycle a 747 that went from London to Los Angeles, and you can recycle that in 3 hours, 2-3 hours maybe, and do another flight. We got to ultimately get rockets to that point.
The tilt of the rocket when it's coming down? Kind of explain.
The reason it's tilting is because it was quite windy. So it had winds up to 50 miles an hour as it was coming down. So it's tilting into the wind.
Okay, question right here.
Hi, Josh Jenner with theorbital.space. First off, I just want to say congratulations. Secondly, I want to ask about the Falcon 9 Heavy. Given that it's going to be going further and faster, what will be the reuse capabilities of those stages?
Falcon Heavy. I must say, thinking about that is like quite a high pucker factor about Falcon Heavy. That's we originally. I mean, maybe we should have named it the Falcon 27. We thought maybe that people might balk at that. It's a lot of engines to work simultaneously, and you have 3 times as many separation events. So it's a lot trickier of a proposition than Falcon 9. But the payload capabilities are amazing, and it's got a lot of potential. And particularly for doing the heavy, high altitude geostationary satellites, that currently can only be flown by Ariane, like that, or if it's a really heavy satellite. Good. Yeah. So that's that's going to be an important mission for showing that we can do the biggest satellites in the world and then some. If Falcon Heavy, if it reaches orbit, it'll be the biggest rocket to reach orbit since, since by thrust since the space shuttle and the and Saturn V, and it'll be the biggest operating rocket today until SLS is active. It'd be liftoff thrust approaching 5 million pounds. Saturn V and the shuttle were about 7.5.
Here, let's take a question here, and then we'll do some social media.
Yeah, J.D. Taylor with USA and Space. Again, congratulations, and also congratulations on your Model 3 launch as well. How often do you plan to do ground landings, and when is the next one that you're going to attempt to do?
Right now, we expect about half of our landings to be ground, and then half to be ocean landings. And then over time, we do want to, as we refine the performance of the rocket, and it can improve just all the elements of flight. And it's amazing how sort of a few percent improvement here and there sort of adds up, and then you're able to achieve enough margin to bring it all the way back to land. So we're hopeful that in the long run, we'll move from, say, half of our missions being ocean landing to maybe a third of them or a quarter. Because it certainly is a lot easier to refly the rocket if it comes back to land. Sorry, what was the other part of the question?
Just when's the next landing for?
Next landing, I think it's probably about 3 months away. So the next one's another ocean landing.
It's 2 ocean landings, 2 GEOs, and then there's another CS mission, maybe that.
Yeah, I think that's probably the most likely.
End of June.
Yeah, so probably the third mission from now will be a land landing. The next 2 are quite high velocity GEO missions. So these will be quite tough ship landings because it's going to come in really hot. In fact, the thing about the high velocity reentries is that they're not just, it's not just a lot of wind force, but it's a lot of heat. And that the heat goes, peak heating goes with the cube of velocity. So like the way to understand the difficulty of achieving a given velocity is actually as the square, because the kinetic energy grows as the square of velocity, but then the peak heating grows as the cube of velocity. So it's really wants to melt.
I think we've got a question on social media. Can you give us that one?
Sure. We have a lot of questions on social media. This one's from NASA Watch, and he wants to know, how many times do you think you can reuse a used first stage?
I think some aspects of the stage will have no meaningful life. I mean, meaning you could probably do them at 1,000 missions. I think almost everything on the stage will be good for 10 or 20 missions. With minor refurbishment, you could get to 100.
This one is from Bart on Twitter, and they ask, can you, this might be for the NASA folks, can you talk about the schedule for the upcoming beam deployment on ISS? I don't know first.
Sure. So beam's going to be installed. We're thinking about the 15th or 16th of this month, so relatively quickly after Dragon arrives. There's a certain period for thermal stabilization once it arrives. And then the inflation is probably not until the end of May, somewhere around the 25th, 26th of May. There's a lot of work involved in preparing for that, and we also want a good quiescent period on board the International Space Station. As I mentioned earlier, we've had 4 visiting vehicles. This will be the 4th in 4 weeks. So we need a time when vehicles aren't coming and going. It turns out there's a high sun angle in the end of May, which vehicles can't come and go during that time, and so it'll be a great time to inflate beam. So we're expect about the 25th or 6th of May for inflation, and like I said, tax day for installation on ISS.
Okay, let's come up here and take a question right here in the front.
Hi, Thaddeus Cesare with the Utica Phoenix. And for Elon, I was wondering if you foresee any competing launch providers following suit with reliability or reusability, and was that a hope of yours?
It is.
And what kind of edge does reusability give you over your competitors?
I think I'm hopeful that the other launch providers will head in the direction of reusability. I think it's quite fundamental. I mean, it's just as fundamental in rocketry as it is in other forms of transport, such as cars or planes or bicycles or anything. The cost to refuel our rocket or reload, which is actually mostly oxygen on board, is only about $200,000 to $300,000. But the cost of the rocket itself is $60 million. You know, it's kind of like an aircraft. Aircraft are real expensive, but not to buy, to construct and buy, but not expensive to refuel, relatively speaking. So, so it's really quite fundamental. Like the potential, if you've got a rocket that can be fully and rapidly reused, it's somewhere on the order of 100-fold cost reduction in marginal cost. You still have your fixed cost, but in marginal cost, it's 100-fold reduction.
Jerini Mom with CNN. This is for Mr. Musk. Congratulations. And is there anything that you and your companies are working on that can top the experience that you've had today?
Well, this is a good one, for sure. I think, yeah, I mean, I don't know about you, Hans, but I mean, I think that getting to orbit for the first time was, I mean, that was probably the best one. You know, way back up through 2008, we managed to do 3 launches, but they failed. And I actually only had the money for 3 launches, but we managed to, that was the original plan. Well, after 3, if we haven't succeeded, well, you know, maybe that should be, that's it. But we managed to scramble and put together the parts for one final launch, and it worked. So that launch 4 of Falcon 1 was, I think, the most profound. And then, you know, first launch Falcon 9, first launch Dragon, bringing Dragon back, landing back at the Cape. I'd say for landing back at the Cape was next best after just getting to orbit in the first place.
Yeah, absolutely.
And as for things in the future, I think we'll be successful, ironically, when it becomes boring. You know. So when it's like, oh yeah, another landing, okay, no news there. That's actually when it'll be successful. You know, there's still you know, a few more things we want to do. We want to try to bring the fairing, the big nose cone back, and that'll certainly help because each of those cost several million. You know, Falcon Heavy should be quite exciting. Seeing 3 boosters come back.
Okay, let's take a question right here.
Mark Gotch, Historical Space Imagery. Elon, congratulations. Once again, you have proved to the world that you can land your rockets, whether it be on land or on a drone ship on the water. But looking forward to this future, looking at your rockets being recovered and being reusable, looking at your success with the Dragon capsule in terms of its abort test, protecting astronauts' lives for the future, looking at coupling that with your rockets, we see the foreseeable future of manned spaceflight at a very economical rate. Can you tell me, you pursuing more landings on water versus land, when will you begin to go forward to your future of manned spaceflight?
Well, the first test flights with astronauts working with NASA. Hopefully, that first flight will occur towards the end of next year. So that's going to be real exciting. We're nearing the completion of Dragon 2, and we'll first do an unmanned test flight, and then add crew. And we obviously want to be super careful and make sure that things are as safe as they possibly can be. But yeah, it could be as soon as next year that we do the first crewed space flight. And I just like to take a moment. The SpaceX has got 5,000 people, and I get a lot of attention, but they really did the work.
Is it true you are a success right across the board? And again, as you say, you couldn't have done any of this without your dedicated people.
Yeah, it's an awesome team.
Thank you, sir.
Thanks.
All right, let's take a couple on the phone here. Chris Ryan from Chris Davenport from the Washington Post, I think, is on the line.
Mr. Davenport, your line is open.
All right. Any others on the phone? Okay, Ryan Ruggiero.
Mr. Ruggiero, your line is open.
All right, let's come back here. We'll take about 2 more questions, and that'll wrap us up. Any more over here? All right, we got one over here.
Robin C. Mangle with the New York Observer. Elon, you always mention that reusable rockets is the long-term goal of that is to make colonization on Mars cheaper and sustainable. Can you give us an update on Mars and the company's plans, long-term plans?
Well, I think probably now is not the time to give a sort of full update. I am planning on giving a talk at the International Astronautical Congress, which will be in Mexico this year in September, and I thought that would be a good venue to describe what we think would be a good approach, something that would be effective for establishing a city on Mars. I think it's going to sound pretty crazy, so it should be at least entertaining.
All right, with that, we're going to wrap up our launch coverage here for SpaceX CRS-8, and hopefully you'll look forward to our grapple coverage coming up on Sunday morning. So with that, that will conclude our briefing. Thank you very much.